Welcome back to The Explainer. Today, we are tackling an absolutely massive topic. We hear the term the cloud thrown around constantly. And honestly, it sounds so abstract, doesn't it? It's like your data is just magically floating around in the sky, instantly available the second you pull out your phone. But today, our goal is to take that abstract concept and ground it in pure physical reality. Because when you're architecting enterprise applications, understanding the literal ground you're building on, that is the difference between a system that casually survives a natural disaster and one that goes offline for days. I want to kick things off with this incredibly hard-hitting quote straight from our source material today. In the cloud, serverless is a lie. I absolutely love this because it just instantly shatters that illusion of a magical, invisible cloud. Okay, let's really dive into this. Even if you're using advanced serverless technology, the truth is, physics is unforgiving. There are always real physical servers, real fiber optic cables running across the ocean floor, and real power grids. And because these things are tangible, physical objects, they carry very real physical risks. To navigate all of this, here's our survival guide roadmap for today. We're going to cover the physical cloud reality, then AWS regions, availability zones, edge locations, and finally, architecting for disasters. Let's jump right into Section 1, the physical cloud reality, where we have to accept that hardware failures happen. Look, because hardware is physical, it breaks. It's just a fact. AWS data centers are vulnerable to the exact same things any normal building is vulnerable to. We're talking massive power grid failures, floods, earthquakes, or even just a fiber optic cable getting accidentally cut by a local construction crew. The whole AWS Global Infrastructure exists precisely to give you geographical isolation. It lets your applications survive these unavoidable catastrophes by turning global data center deployment into a simple software API call. Which brings us to Section 2, regions, or what we can think of as the metro areas. This is the highest macro level of the AWS geographic hierarchy. Now, what's genuinely wild about this map is the sheer global scale of these connected points. Every orange dot you see there represents a cluster of physical facilities, and they're all connected by an incredibly complex web of high bandwidth, fully redundant, dedicated metro fiber networks. I mean, this isn't just the public internet. This is a highly controlled, private, global backbone. So, what exactly is a region? Technically speaking, it's a specific metropolitan area anywhere in the world, places like New York, London, or Tokyo, where AWS physically clusters its data centers. As an architect, picking your region is your very first major decision, and it basically comes down to three things. First, proximity. You can't beat the speed of light, so you want your compute power as close to your users as possible to cut down on latency. Second is pricing, because costs actually do vary from region to region. And third, compliance. Data sovereignty laws might literally dictate that your user data cannot legally leave a specific country, so you have to deploy in that local region. But a region is basically an entire city. Let's zoom in a layer deeper for Section 3, availability zones, which we'll call the hotels. Think of a region like a massive global hotel franchise spread out across a major city. And availability zone, or AZ, is a specific hotel building in that city. And this perfectly illustrates the genius of the architecture. Each AZ is made up of one or more discrete physical data centers, and they have completely independent utility power, cooling, and network connectivity. So, if a hurricane hits and floods the hotel on the east side of town, the other hotel, completely across town, is totally fine. They are physically isolated from each other to stop a localized disaster from taking down the whole city, but they're connected fast enough to still give you single-digit millisecond latency. All right, let's zoom in one more time for Section 4. Edge locations, our express kiosks. This takes us right to the very edge of the user's internet experience. An edge location is a much smaller facility placed in major cities worldwide. Going back to our analogy, if the region is the city and the AZ is the main hotel, the edge location is like a tiny express kiosk right inside the airport. It doesn't have beds, meaning, it doesn't hold your heavy database servers, but it holds maps and brochures. Services like Amazon CloudFront use these edge locations to cache static assets like images, CSS, and videos right there at the kiosk. So a user in Australia can grab your website's images locally from a Sydney edge location in milliseconds, rather than traveling all the way back across the ocean to your main servers in Virginia. Let's see how this edge infrastructure builds into this incredible service called AWS Global Accelerator. For dynamic traffic that you just can't cache, the standard public internet is honestly a nightmare. It's like forcing your users to take public buses to your office. They're transferring lines, dealing with random traffic jams.
Global Accelerator completely changes the game. It gives your app two static Anycast IP addresses. When a user hits that IP, it's literally like dispatching a private helicopter. They get picked up at the nearest edge location landing pad and flown directly to your servers over the private AWS fiber optic network. You completely bypass all that public internet congestion.
So, we've got the tools. Now let's see how we use them in Section 5, Architecting for Disasters. The holy grail here is high availability, or HA. High availability is all about guaranteeing an agreed level of operational uptime by ruthlessly eliminating single points of failure. It's the art of taking those physical hardware failures we talked about earlier and abstracting them entirely away from your end user. Literally, if a server dies, the user shouldn't even notice a blip. The absolute best way to understand this is to look at a commercial airplane. A commercial jet has two engines, 3 flight computers, and 2 human pilots. Why? Because if one engine catches fire mid-flight, the plane does not just fall out of the sky. The second engine instantly takes over the load. Architecting for the cloud means building your software exactly like that commercial airplane. If your application relies on a single database sitting in a single availability zone, my friend, you are flying a one-engine airplane. When you systematically eliminate those single points of failure, you can start aiming for the pinnacle of enterprise cloud reliability. It's a metric known in the industry as 5 nines, or 99.999% availability. Just to put that into perspective, that translates to roughly 5 minutes of allowed downtime per entire year. It's wild. But achieving those 5 nines requires a very specific setup. Step 1, you deploy your application compute, like your EC2 instances, across at least 2 physically separated availability zones. Step 2, you drop an elastic load balancer in front of them to intelligently split your incoming network traffic evenly across your healthy fleet. And step 3, if an availability zone gets hit with a power outage and the instances inside it die, the load balancer instantly spots the failure. It automatically routes all new user traffic exclusively to the surviving instances in the healthy zone. Boom, zero downtime for the end user. So, the absolutely crucial takeaway here is understanding the shared responsibility model. Yes, AWS provides this incredibly resilient global infrastructure. They are completely responsible for the security and operational uptime of the cloud, meaning the literal concrete buildings, the power generators, those fiber optic cables. But you are responsible for what happens in the cloud. AWS is not going to automatically magically duplicate your application across multiple availability zones for you. You have to actively architect it that way yourself. Which leaves us with one final, very real thought to wrap up this explainer. You now know that the cloud is physical, and physical disasters are simply inevitable. So take a hard look at your own architecture. If an earthquake strikes your primary AWS region tomorrow and knocks out a data center, will your app seamlessly stay online, or did you build a one-engine airplane? Think about that as you design your next system. Thanks so much for joining me, and I'll catch you in the next one.